at the heart of science is physics. And of course, what's better way to define the nature but of its physical quality, right? Physical qualities. So we utilize physics to understand as comprehensively as possible the natural world. And to introduce you, of course, we need to have a way to set the things that we are going to measure. Alright, so on the review, we have tackled SI units, correct? Then we have tackled dimensional analysis. And what else? What's the other one? Scientific notation. So SI units covered what measurement is and how it creates meaning on our understanding of the natural world. Now, as the first lesson in physics, I'm going to introduce you how we quantify those quantities. So we have scalar and vector measurements. Okay, or scalar and vector quantities. So when we say scalar, it only tackles the magnitude or just the measurement. Okay, so for example, you walk, let's say 50 meters, or you weigh, let's say 50 kilograms. Okay, or you're biking at a speed of 10 meters per second, let's say. Okay, for vectors, it includes magnitude and direction. Okay. So what would be the examples of that? Let's say, what did I say earlier? You're walking 50 meters. Let's say going to the north. Okay. Or you're biking for 10 meters per second going to the east. Okay, so that's basically the difference between scalar quantities and vector quantities. So there would be some measurements that are exclusively scalar, and there would be measurements that can either be scalar or vector. You can review those on the PowerPoint presentation. Okay, so but now we're going to focus on vector representation, then vector addition. So we represent vectors as arrows. So an example with that would be something like this, or something like this, or something like this. Okay, so a vector is represented by an arrow with an arrow tail and an arrowhead. Okay, the length specifies the magnitude. Let's say this is 10 meters. So this side is the magnitude. Okay, so that would be the length, or how long would be that particular magnitude is. Don't worry, it's just a representation, but it's a good thing that you can somehow estimate the variation between the lengths of the arrows if you're going to represent them. Okay, then the second one would be, of course, the direction. So this is going to the east. Okay, so this would be your direction. Okay, so for this, let's say this is 50 meters going to the north. Then let's say this is, let's say 30 meters, 45 degrees. 45 degrees, what's that, southwest. Okay, so this one we're going to cover later. For now, we're going to have this. Okay, next one would be the variables. Okay, so we represent vectors when they are in variable form as letters, of course. So let's say this is vector A. So we place a small arrowhead on top of it to represent that it's a vector. So let's say this is your vector, so the magnitude is 10 meters east. So that would be the name of it. Okay, next would be this one. So let's say this is vector B. Okay, so our vector B is 50 meters going to the north. Okay, then of course for our vector C, so let's say this is vector C, so that would be 30 meters, 45 degrees southwest. Alright, okay. Next, let's discuss vector addition. Okay, so of course you don't just walk in a single direction, right? You take turns, you detour, etc. So of course the displacement that you're going to accumulate will increase. So for us to quantify those, we of course add them, and we call that vector addition. Okay, so basically you're just going to add the magnitude and consider the direction when adding those vectors. Okay, so this is the easiest one when the vectors are on the same axis. Okay, so in this case we have vectors on the x-axis. Alright, so let's say this vector, so let's name this one vector A, okay, is going to the east, of course, at let's say 20 meters. Okay, then we have vector B, which is, let's say, 5 meters going to the east as well. Okay, so when adding, we term the result or the total as the resultant vector, which is represented by R with an arrowhead. I mean an arrow on top of it. Okay, so if it's going to the same direction, of course you're just going to add them. So that would be 20 plus 5, is, so 20 meters plus 5 meters is equal to 25 meters. Okay, and the direction is still going to the east, correct? Alright, so how about on the second case? Let's say we have vector C, which is going here. Okay, let's say this is again 20 meters going to the east. Okay, but then our vector D is 5 meters but is going to the west. Okay, so you're going to notice that it's on the opposite direction. Okay, so what would happen? So this would be 20 meters. Okay, so since this is going to the west, set that as negative. Okay, so your answer would be 15 meters, correct? And what would be the direction? So you're going to take the sign of, the sign of the larger magnitude. So in this case, that's 20 meters. So that one is going to the east. So you set that as east. Okay. So for our third example, so let's say our vector E is going the direction of, let's say, 10 meters going to the east, and then this one, vector F, is 30 meters going to the west. Okay, so for our equation, so that would be 10 meters, so that's positive. So this is minus 30, which is equal to negative 20 meters. Alright, so of course this indicates that the higher magnitude is the one that is going to the west. So you just change that and indicate that it's going to the west. Okay, so that's it. It's easy. Same thing for going to the north and going to the south. Okay, so take note for the cardinal directions. Okay, so if you're going to the north and going to the east, alright, so magnitude is positive. Okay, then if you're going to the south and west, west, okay, so magnitude is negative. Alright, so I hope you understand that. Don't forget to revert the sign after assigning the direction. Okay, so